destination that your highest paying customers are using to terminate voice calls or IPVPNs or something like that, then the value of that traffic is very high to you. So if you have to send it as a preferred path via the more expensive link, if it keeps your highest paying customers happy, you're probably willing to do that. So this is where you have the context of how much traffic you have comes in, and analysing what that traffic might be. Generically, I'm not saying look in the traffic and see if it's movies, pictures, whatever. I'm saying, if it looks like the destination network is a VoIP network used by your top customers, for example, then it's not just general traffic. You should care about it a little bit more, and maybe want to work with the destination network to find out why they're trying to signal to you that the other path is less preferred. Here's some config examples that can do the deterministic routing. So if we think back to the example where my suggestion to you is that for your top N networks, and N is the number that is right for you depending on how many networks you appear to have a lot of traffic to. Remember, I'm saying that you should configure a preferred path and a deterministic failover path for your top N networks. Here's an example of how this might be done over 2 exchange points. So you build the largest flows are to the 6 ASNs that's listed in the 2 access lists on this config example, access list 30 and 40, and deterministic exits via 2 internet exchange points have been configured in this example, so that if exchange point EX1 is up, then the AS is 7018, 2828, 4323, etc., the access list 30, these ASs get a higher local pref over exchange point 1, and over exchange point 2, access list 40, 3330 gets a higher local pref. So deterministically, where there is no failure, your top destinations are being delivered to specific egress options on your network, and in the event of a failure, because the next local pref is 200, the traffic will move onto another deterministic link. It's not that some might go on transit, some might go on a different exchange point. You've got deterministic preferred exit, deterministic backup exit for your top ASNs. I think maybe I've done this example to death now. It's clear, right? Cool. Let's perhaps look at, again, a mainly outbound network, but this time the network has got many points of presence. So here, we introduce the concept of hot potato routing. It's another word for hot potato is nearest exit. You're trying to deliver the traffic to another network at the closest point to where on your own network you generate that traffic. Once again, this scenario of network needs you to understand who your top traffic sinks are. Where are you sending the most traffic to? And the way to deal with, the way to encourage hot potato routing on your network for your top traffic sinks is to peer with those top traffic sinks at all the places where you have a mutual POP. And I'll cover what this means in a moment in more detail, and ignore the med attributes from others. I'll cover what that means in a moment. Here we have a slightly more complex example then of the previous network. So we've got a network that's in 3 points of presence around Europe. I've picked Berlin, Frankfurt, Amsterdam. They have a number of private peerings, a number of exchange point peerings. Here, what the example here is that, if you lose a point of presence, if you lose, say, Amsterdam at this point, does the traffic go away altogether, or does it move? Can you run Amsterdam as an island, or does the traffic just move somewhere else? Because in the context of most people's networks, their internal backbone links are more expensive than IP transit or peered links. So if you end up losing a POP on your network, that's the analysis that you need to do. Where does that traffic go in this scenario? And you can see that what you might be doing is sending, in this example, Amsterdam. It makes a little bit more sense in Europe, this slide, because Amsterdam and Berlin are much further away than Frankfurt. Yet you've got a peering with AS1 and AS2 out of Amsterdam, by default, you may well be carrying all that traffic to Berlin when it might just be much more sensible to hand the traffic off to a transit provider in Frankfurt because it's a nearest city. You're carrying it on your network for the lowest amount of time. And handing off at the nearest city helps keep the traffic local, stopping the traffic travelling, in this case, across Europe and back, if the other network that you're sending to is in Amsterdam as well. So this, I remember the example now. This is why it's a key point here. If you lose a POP, are you going to be carrying the traffic a long, long way because that's the way you've got the next nearest peer? And if you understand that, if you understand what happens if you lose a POP to your top traffic destinations, then you'll cope with both traffic growth and the failures of core links. So those are two outbound examples. I'll just recap those. It's really, for outbound heavy networks, much easier. You can use deterministic routing to your best effect, and that means that traffic will leave via specific means and not left to BGP best path selection algorithms, bottom options, or to chance. Basically, it's the same thing as leaving it to chance. If you're leaving traffic, if you're relying on the oldest route installed in your RIB, then your traffic will take completely unpredictable directions in the event of a failure. Let's look at some inbound traffic engineering examples. This is much harder again because you're having to trick other people's best path selection algorithms. You've got to try and get them you've got to try and shape the way that they handle their selection algorithm in order for you to move how your traffic reaches you. And you don't administrate that router, you don't administer the other router. But remember, it's not impossible because, as I keep saying, if you're a typical network, your largest flows will be with a relatively small number of ASs. And if you've got traffic to somebody and you've got a large amount of traffic to somebody, it's in their interests to work with you and deliver it properly to your network as well. It's not in anybody's interest to ignore each other and leave traffic to chance. So it's not impossible. It's harder, but it's not impossible. Now, this is a technique that comes with a big health warning, and I'll say that right now and a few times during the explanation of this. If you're going to use this technique, you've got to look at this entire example, and it's very, very important you follow all the steps in this if you're going to use this. You can shape inbound traffic engineering very, very aggressively by announcing shorter prefixes to some of your peers or some of your destination networks. The reason that this works is that prefix length is considered before the best path selection algorithm. So here, if you've got this /16 inside 10net, you can see that by splitting it into 2/17s, your peer network will see the deaggregated prefixes and not even start best path selection algorithm. It will say, this is the shortest prefix, so I'm going to send the traffic this way. Now, there are problems with just doing that. You can't just say, hey, I'm an inbound heavy network, I'm going to do selective announcements everywhere to my peers. It's going to be fine, because it's not. Selective announcements are often considered quite rude, quite aggressive, and they could mean that, yes, for as long as the peering's up, your inbound traffic's coming in the right way, but it may, if you're doing this, if you've really got 3 or 4 prefixes when aggregated on the internet and you're sending your peers 20 or 30 prefixes, then they may well end up de-peering you. And in order to be a good internet citizen, it's really important that you don't announce your selective deaggregates globally, because, well, see every single nanob since the beginning of time for why that's bad. It gets discussed every time. But it can be used to really, really great effect in specific circumstances. So if you, normally, you do this when you work with a peer and you say, you're interested in delivering traffic to my customers in the best way possible. It's in both of our interests for me to give you a hand, and selective announcements may be the best way to do this. So if you peer, for example, with the same peer or the same transit provider in multiple locations, you can announce the aggregate prefix in all of your locations and regional selective announcements that just have customers in that particular region in it. You have to use it with permission, really. You have to work with the peer to check that it's acceptable to do that. And agree that you have a mutual interest in doing selective announcements. And it works really, really well. It's the best way of shaping inbound traffic. But if you're going to do this with your transit provider, it's very important that you use the no export community on the de-aggregates that you announce as a transit provider, so that the transit provider isn't announcing those onto the default free zone. Does that make sense? Okay. So inbound traffic engineering, another blunt tool is de-aggregation, but a typical way that people handle inbound traffic engineering to good effect as well is AS path prepending. Now, this is a technique that allows you to signal a path, an ingress path into your network may be less preferred than another ingress path on your network, because you artificially make the AS path length longer by putting your own AS number in it more than once. So by default, you'll be in there once, you put it in there 2 times, 3 times. That path looks like a less preferred path by default to your peer networks. Now, this has a marginal effect. It normally works pretty well when you make maybe prepend once, so your AS appears 2 times. But it degrades quickly, which means that if you then make it appear 3 times, the effect is less big. 4 times, the effect is much less big. 5 times, probably very little or no effect at all. And we all see people prepending their AS 100 times or something in the default free zone, and the conclusion is always, well, that must be a typo, right? Because by the time that you've done this 4 times, the effect really, really does fall away in my experience. Now, it can be used where it's most effective is where you have more than one BGP intersection with the same distant AS or the same remote AS, same peer AS. And you can signal to this network whether they're in the same city, you want one to be a preferred link and one to be a backup link. So that works really, really, really well. But it may not be heard because, remember, your transit networks, and people will take the shortest AS path normally, unless they're using local pref to route differently. Your longest AS paths may not even appear at distant ASs. So someone who's 3 or 4 real ASs away from you may only actually see the shortest path, not the longest path, and there's no way you can influence that. For that reason, it's another fairly blunt tool, but it can move some traffic. If you have a link, if you have 2 links onto your network which you consider fairly equivalent and you want to balance them for simplicity reasons, you may find that prepending via one of those links just causes that to happen. I've certainly seen that in the past. You can, now you've got a lot more control. Imagine a world where you can signal to your transit provider, what I'd like you to do is prepend in this direction, but not prepend in this direction. And you'll often find that your transit provider has given you a tool that lets you do that. So we'll talk about how it works and then why it might work in a moment. Here I've put, whose network is this? 3320 Deutsche Telekom. So this is, these are the community widgets that this network gives you to influence the way that they will handle your traffic as a customer. So let me see, how should I explain this? So this one here, Deutsche Telekom is giving you widgets that allow you to prepend their AS in the middle when they send your traffic or your prefixes to a specific peer or to an upstream or to a region. So if you are happy with that transit, but you find that you often have poor performance to a specific AS who Deutsche Telekom in this case peer with, you can send your prefixes to Deutsche Telekom without any prepending and signal to them, but I want you to prepend 2 times just to this AS. And that will cause you to be able to influence your inbound traffic via your transit provider to try and cause a completely different third-party network to use a different route onto your network. So this is a much more finely grained way of doing AS path prepending, if your transit provider supports it, than just prepending straight to your transit provider. And it works enormously well for handling times where you're happy with your transit provider, they're working out for you, you like the price, you like the service, but there's one particular link that they have that gives you some headaches. You can just make that problem, you can just mask that problem so that you're influencing that third-party network to use some other route to your network. And that works really, really well. You can do this by attaching the community to the prefix when you send it to your transit provider. Here, the no export community, you can actually turn off the announcement. If you're saying that the interconnection between your transit provider and a third-party network is so bad, you can also use communities to signal that you shouldn't send your prefix to that third party whatsoever via transit, which is really, really cool, really handy. So we've talked about ASPath prepending being the blunt tool that often works. We've talked about how you can get your transit provider to signal the ASPath prepending. Some other techniques can be useful. The MED is a really, really handy tool in this scenario. It causes you, remember I talked about if you're an outbound network and you want to do and you have multiple POPs, you'd normally want to send traffic out at the closest point to where you originate the traffic. In this scenario, having MEDs, it's the opposite of that. It means carry the traffic on your network for as long as you can, so that you hand it to me as close to the customer as possible, not as close to where the content's generated as possible. It only works when you're sending to the same peer. So if you send MEDs via transit provider A and transit provider B, that's kind of contextless, kind of meaningless. If you send the MEDs to transit provider A in 2 different cities and you're sending different MEDs in both cities, that will cause traffic to come to you in different ways, so that on one prefix, if you signaled, I'd like the traffic to be carried to me to this city for this prefix, you'll get the traffic in on that city, as long as they're not filtering your MEDs. Normally, your transit provider, by default in my experience, transit providers are quite happy to take an honor MEDs. By default, peers are probably less likely to take an honor MEDs because of the different types of relationship that is. Are there any peers, people who peer in the room, who honor MEDs? Yep, I can see a couple. Is that, do you want to say anything about why? Exactly, and that's I've seen MEDs work really, really well where traffic is high value, traffic for one or both of the parties. Another example is, for example, in voice networks where VoIP companies might say, my backbone is entirely over-provisioned. I upgrade a link when it hits 20% because I'm so latency sensitive, I'm so loss sensitive, and the traffic, my traffic, I bill by the minute, right? So I really want this to work all the time. And you see voice companies sometimes saying, we'll peer with you at lots of exchanges, we'll peer with you widely, and you can send me your MEDs because my backbone is uncongested, and if you tell me, I'll carry the traffic to where your customer is because I want to make as much money as I can, and it's better for me to carry it on my backbone than it is for me to think your backbone's always going to work. So a lot of the time peers drop MEDs, but sometimes we've heard a couple of examples today where peers say, I'll honour your MEDs, and the best way to deal with, to understand whether it's going to work is to talk to the peer. I've put the example on the slide of how to flatten MEDs. If you specifically don't want to carry MEDs, that's how you do it. But a much better solution is to work with your peers and find out why they're trying to send them to you. The other really hacky thing that works quite well is actually changing the origin attribute on a prefix, which again should only be done in probably should only be done where you found other things haven't worked and you're really struggling to make a contact with a peer or something. But this is another hacky thing that kind of works. The way that this works, if the AS path is equal length, if the local pref is equal value, eventually the BGP best path selection algorithm will decide to look at the origin, whether the origin is set to, it's kind of really a flag, IGP, EGP or incomplete, and it gives prefix, an occasion where it learns a prefix via an origin that's set to IGP, preference over one where the flag is set to EGP, and over one where the flag is set to origin. So sometimes, often peers set to IGP or EGP by default to nullify the effects of you doing this, but this again does work if actually talking to people has failed sometimes, to allow you to influence inbound traffic to you where you're expecting local pref and AS path length to be the same. But what does, for inbound traffic engineering, what actually works really, really well? And what works really, really well is over-provisioning, peering with the top networks, so going back to your data, working out who the most important, from a traffic volume point of view, networks are, and peering with them really widely. So that failures of a single link don't cause unexpected breakings, and failures can be handled in predictable ways. But the thing that works really, really, really well is building relationships with those top end networks that are sending you traffic. Constantly monitor and manage that traffic, and try not to play peering games to influence to earn yourself new peers, because it probably won't work in the long run. Working and selective announcements and managing meds and origin changing are hacks. Building a relationship with peers works long term. What does managed relationships actually mean? And for about the 10th time, I would say go back to your data and share that. Collect and share data with peering coordinators at forums just like this one. Because if you're an inbound heavy network, if you're an eyeball network and you're trying to get peering with people, if you can go and talk to your target peers and you know exactly how much traffic you have at a particular exchange to swap with a network, when the peak of that traffic is, and who to go and talk to, then you're going to stand out head and shoulders above a lot of your competitors who are just firing off emails. Hey, do you want a peer? If you can go and shake someone's hand and say, this is my instrumentation, this is the data that I have, and I care about this traffic, and I think you care about this traffic, and I think we should peer, you literally do stand head and shoulders above, and you'll get some of the sessions that you wouldn't have done otherwise. The other thing you need to do is have a reputation for protecting your peers' interests. So really this is a traffic engineering talk, but for inbound traffic engineering, if peering widely is the only thing that works really well, you've got to protect your peers' interests, which means responding to abuse complaints really, really quickly, responding to their messages about BGP sessions flapping or whatever, and listing your network on peering DB, very important. Something else you can do, or you need to do if you're going to traffic engineer, is buy your transit in a smart way. Do you buy your transit from the person who says, I have the lowest price? Sometimes, yeah. But if you make an active and informed decision about who to buy your transit from, it can improve the quality of your inbound traffic performance anyway, because if you believe that peering widely is best, and you buy capacity from a well-peered network, then you get the benefit of them having the same values and them having the same attitudes toward peering widely as you do. So if you believe that the things I say are true, and I think they are, then buying from someone who shares those values will improve your traffic quality. Buying traffic from your top destination, if you really rely on, if say a third of your traffic comes from a single AS or goes to a single AS, then maybe you just want to buy transit from them, because if the traffic is high value, if it's a lot of money for you that this works, maybe instead of just relying on a handshake agreement, you might want to put a contract around that, because if it's a third of your revenue and a third of your traffic, for example, it's really, really important. So even though peering, of course, is the holy grail, actually service availability and service performances. And if you know that your top destination will sell you transit at a price that's fair and reasonable, then suddenly a third of your traffic has a contract wrapped around it saying that it should be available and should work. Oh, and if you know that a lot of that traffic's going to stay on net at that network, you might be able to negotiate a better price anyway. So go back to your data. I want to have a bit of a discussion. I want to have a few minutes for discussion, so I might jump through the last couple of slides relatively quickly. From dealing with a no to peering, my favourite one here is peering around the problem. If someone says they won't peer with you, go and peer with their customers, or try and sell bandwidth to the customers, because you can say to the customers, hey, I'm a better peered network than your current transit provider, and sometimes that works. What I'll do, I really do want to have 20 minutes for discussion, so I'm going to zip onto the last slide. The thing to take away is that peering on the internet, because it changes every day and capacity on the internet grows every day, small networks become large networks become even larger. A bad path might change overnight, so it's really, really, really important. If you're going to do traffic engineering, the thing you need more than anything else, the thing you need more than anything whatsoever is data. It's really, really, really important. And starting out with data that you can analyze from time to time is good. Building instrumentation that gives you real-time information is better. And just starting out with a snapshot in time is better than having no data at all. And it's something you can build on into the holy grail of real-time information about your top traffic sinks, destinations. You'll ultimately one day use it for abuse prevention and abuse mitigation. But just starting out by dealing with your traffic more effectively is a good place, right? So build the data. What I want to do now, I think we have until 11 o'clock, so there's 20 minutes. I'd really, really, really love to hear some stories from people in the room who might say, your idea sucks, I tried it and it doesn't work, but this is why, and so we can have a discussion, or if someone in the room wants to say, your idea worked really well for me when I did this, that's really cool. So if anyone would be willing to get us going just for 20 minutes, I can see, are you standing up to speak? No?
There's a microphone over here.
Oh, excellent, there's a microphone. So we've got a question already. Remember to say your name though, please.
Victor Liu, Huawei Technologies.
Hi.
End of August, I was attending at a conference called Op Network. There's a traffic engineering session, including a BGP talk. It provides a very nice simulation tool. Basically, if you want to peer with someone, you can just, simulate that environment and see how your traffic got impacted. Of course, yours is also excellent. And
thank you.
Actually, all this kind of topic brought me a very strong interest to study the economic view of this kind of peering and what will happen down the road. Because any peering link will change your topology, will change your traffic distributions, and all things changed.
Yes.
Have you been doing anything like this? Or maybe the audience here can comment on that too.
So, yeah, when you peer widely and when you turn up a new peer and it causes a lot of traffic to swing, your topology definitely changes, absolutely. But that's what you want. You often want to move this traffic off an expensive link or an unreliable link or something onto a link that you specifically prefer. And if you have a preferred link and a backup link and you know those two are resilient for those purposes, then that's really, really good. So I don't think it's a danger, excuse me, I don't think it's a bad thing that your topology changes, it's what you want. In terms of getting information, if you can overlay, it's about data and instrumentation again. So if you have a weather map on your network that shows you the utilization and when you make a change, what changes, can I explain things? Am I keeping my knocking phone? Are they talking to me properly? I think that's how you deal with the topology change and from a predictability and a reliability point of view. But I'd be interested to hear, if people in the room have got horror stories about that happening and what they did to deal with it, that's another good thing.
Hey, Andy.
Hey, Guy.
My name's Guy Tall. I work at Verizon Terramark. Fantastic job. I've done similar presentations in the past, and you've really condensed it down very well. I think you hit all of the nuances, that the different traffic engineering methods employ. There's just one thing I was going to mention, and it's really just minor little thing too, but when you were talking about doing the AS path prepending, you were saying that the far side might not see your prepend because the network only selects the best path, but as long as the only thing I was going to say is, if you're doing this AS path prepending to the same upstream, then you still achieve your goal because that network will advertise out only the best path, so the traffic will still come to them. And then once it hits them, the rest of the internet doesn't need to know that you want to use one link of your transit provider versus the other. So
Yeah.
it'll come reach them, and then that decision stays local on that network where the best place you want to get it from them. So it still is. I just want to point
Yes.
out that most of the time, as long as you're only doing this to the one upstream, it still works out. So
Yeah.
it seemed a little like you were saying it might not work, but I think it will work as long as it's only with the one provider.
Yes.
If you do it to multiple providers, then who knows what happens.
Yeah, exactly. It's the same logic as selective prefixes or deaggregates. If you only send them to your transit provider with no exports, then the same logic applies. It doesn't matter that you're doing this kind of dirty thing that's very much a back alley way of dealing with internet engineering, but it's only your transit provider, who PS you are paying, who has to see it and deal with it. So it's your own dirty secret at that point. And it's the same kind of logic.
And then the only other thing I wanted to mention too is, you did make a valid point that you can deaggregate and influence the traffic decision before it even hits BGP, and technically that's true. But working at a carrier, working at a large network, a large content provider in the past, we hate that. Do not do that. It's absolutely, it drives people crazy. A lot of people will filter out your more specifics anyway, so you think you're going to be cute with it until, a lot of people in their peering negotiations, if they actually do a formal one, or a lot of times even if you have an informal, agreement, one thing that almost everybody stresses is having the equal announcements and the consistent announcements. There's got to be better ways. Don't deaggregate, please.
Yeah, I would try and find a halfway position here, because I think a sensible way to react might be to say, if you don't know how to stop those deaggregates from leaving the people that you're sending them to, then don't do them. If you do know how to stop that happening, then it might be something you can do. And if they're your transit provider, they're fair game in my opinion. You're paying them. They might not be making any money, but you're paying them. Yes. Agreed.
Fantastic presentation. My name is Ken Bokino with F5 Networks.
Thank you.
My question was towards traffic engineering around 95th percentile billing, and how you deal with that with bursty traffic with multiple transit providers.
Okay. That's a set of games I haven't personally played. I know that it is a game that can be played, making sure that if you're going to burst, you only burst for a certain amount of time. You probably... I've not done that before. I can imagine the logic is that in your instrumentation you set in your polls, if you poll every 5 minutes, then you've got a day's worth of data that shows you've breached threshold. I guess you could then have a script that goes and down prefs various things automatically until the midnight on the 31st of the month or something. I imagine there's something you could do that's automatic. I imagine there's people in the room who've done it, who's nodding to themselves going, I've saved a lot of money doing this. But it's not something I don't know of a tool that does that or something. Maybe someone in the room does. And it's a valid way of dealing with things. But if this is I guess after I've thought about it, my thoughts are, if this is enough of a problem for you that you're going to save money by building this automation and instrumentation, you should probably just figure out what the traffic that's causing you to burst is and try and peer it off. Because in my opinion, that's going to be cheaper than maintaining a system that's logging into routers all hours of the day and night and might do something wrong. That would be my thought. I don't know, maybe there is a tool that does this stuff automatically, but that would be my thought. If there's enough traffic that's causing you an operational concern, peer it off and then let it grow.
I just want to emphasize, oh sorry, Matt Petak from Yahoo again. I really want to emphasize a point you made in passing. Peering DB is out there. Use it, make sure your information is updated in it. When you're talking to somebody and saying, hey, I've got a bunch of traffic for you, I'd like to peer with your network, one of the first things as a major content provider we do is look up your record in Peering DB. If you don't have a record in Peering DB, right off the bat, it puts you from the clueful category into the, oh God, maybe we'll just pretend we didn't see this email from them category. So first things first, make sure that record is there and make sure you update it. Because when we go to build neighbors, you say, hey, we want a peer, we're going to go into the router and build the peers based on what's in there. And if your IPs aren't correct, if your AS isn't correct, hey, it's not coming up. The other piece is in reference to deaggregation. Before you think about deaggregating, make sure you talk to the people upstream, even if it's a transit provider, because it's really embarrassing when you figure, hey, I can just deaggregate this /16 into /24s to my transit provider, it'll all be fine. What the hell, my max prefix popped and suddenly I have no transit connection anymore? Oh my God, life is sucking for me. They may have a max prefix set against you that looks reasonable based on your IP space, and when you suddenly deaggregate, boom, you pop it, your transit's gone. So yeah, communicate before you do stunts like that.
Great comments. Yeah, that really, yeah, you're absolutely right. If you're going to do selective announcements, if you're going to deaggregate, you've got to work with the people that you're going to do that to. Otherwise, they might just ruin your day back for your attempt at ruining theirs.
Hi, it's Gino Doucette, Bell Line. Part of it was a great presentation, thank you.
Thank you.
From the tools perspective, have you explored any traffic engineering modeling tools, so to analyze failover scenarios and where your traffic will go from, you know, if you lose one of your major peers?
Okay. This will make me sound really lame, but I just use Excel because in the roles where I've worked in the last 10 years, it's been the case that I've said on the in the slides. It's typically max about once I've got about 40 ASs in the list, it's normally I'm talking about 5 to 10% of my traffic that's left over. I know that that's not the case for everybody. It won't be the case for Matt at Yahoo. It won't be the case for anyone at Google, Akamai. But for many access networks, I'm talking about 40 ASs being the stuff that I've got to get right, or maybe less, maybe 20. And I only care about what I'm doing at peak, because that's the number that's the amount of traffic I've got to deal with if I don't want to congest anything. So I've got the peak traffic today. I know roughly how much my traffic's growing. So if I'm doing this exercise every 3 months, and I know my traffic's growing by 10% every 3 months, I take this list of ASs, I take the traffic I'm doing today, add 10%. That's the traffic I've got to deal with on the preferred and the failover path. And then I just tick it off with a pencil or highlight it. And it's a nice job to do with a cup of tea and a biscuit and a spreadsheet, rather than my biscuits are different to yours, I remember now. But it's a nice job to do on a Friday afternoon, and because it's interesting what's changed, what's happened, and I find that doing it manually helps me spot things that I might have missed if a computer's doing the work for me. Like, wow, why is this network from the next city over suddenly in my top 20? They came out of nowhere. I'm going to phone my friend who works there and find out what they're doing, and maybe we can partner and do whatever product is interesting that my customers have started to buy. I want to know this. So, and sometimes traffic engineering is this human element as well, and figuring out why someone jumped in the top. So I tend to do it by hand because I'm interested in why as well as what. Maybe someone knows of a tool better than Excel. I think Anand has a...
Hi, Andy. My name's Anand Buddhav, and I work for the RIPE NCC. I have a question for you and perhaps for the entire room, actually. So we operate Anycast, K-Root Anycast, and we have this model where we announce our prefixes with no export tagged at some of our exchanges, whereas we have other global instances where we don't use no export. So we sometimes get questions from people saying that hurts them because if they're a large provider, they might end up sending their traffic to some of our local instances instead of globals. So my question really is, who else uses this kind of engineering, and what's your opinion about doing this? Because we've been considering dropping the no export and letting the peers decide for themselves whether they want to further propagate our prefix or not.
Yeah, I'd be interested to hear other people's thoughts. I mean, my concern might be if it wasn't done carefully, I might cause my prefix not to appear at my peers' customers' networks or something, because you never know just what people are doing to get to deal with traffic. So if your prefixes become shadowed, then they're not appearing anywhere. If everyone's upstream has got them as no export, because they're not going to go to the customers downstream. You might, it would be interesting to know as well if any of your peers are dropping the no export community. They're saying learn no communities at all from my peers and that sort of thing.
So we have some peers who do drop the who do drop the no export after having consulted with us, because without that, they weren't sending us any traffic at all, and they have a whole bunch of customers that they wanted to propagate the prefix to. So and that works for them. So I think that's something we are looking at doing in the future. But I just wanted opinions from anyone else who might have experience in this area.
I mean, the thing about the RIPE NCC specifically is you guys know just how, whether someone's a transit AS or whether someone's an end AS, and you could build into your peering automation. If someone's probably an end site and they happen to be peering, which is great. I like the end sites that peer, and it's good that they do that, but you can send them no export then. And if they happen to be a transit AS, then send them without. That might work. Sounds like a lot of work. Sounds like a hell of a lot of work. Okay, it's about 5 minutes before the break, so I don't mind taking one-on-one questions or more questions from the room, or if you want to get an early coffee, that's cool as well. There is a question from Matt.
I'll just give a slight alternate view on Anycasting. We also do Anycasting globally, and rather than trying to make use of a no export community to limit it, we actually tag our Anycast routes with our location information. We will try to work with upstream transit provider or peers if they have communities that we can set for limiting the propagation. We tend to see that the big problem with Anycasting is when you start crossing ocean boundaries and things like that. But within a region, we kind of don't care if we hand it to a peer and it turns out that they hand it to somebody else. We more care about saying, look, please don't send the Asia Anycast blocks to the US. That's kind of sucky for the users, kind of sucky for you. You're hauling traffic more than you need to. And again, communication. Most of the time when you talk to networks and say, look, we're trying to make this better for the users, and we're trying to save you money. We really want the traffic to come locally. So if you leak it off to some large tier 1 in the US and you're a customer of that tier 1 in the US, and suddenly all the traffic from that tier 1 in the US goes, oh my God, I can send this to a customer? Hey, I'm sending the traffic that way, even if it's going halfway around the planet. And nobody wins in that situation. So in most cases, when you actually, give them a ring, send them an email and say, look, we really want to be the best for the users we can. What communities or controls do you have to make sure that this anycast prefix stays in the region? And most networks will have some level of control that they say, well, we don't advertise this, but if you send this community, we keep it within the region. If networks don't know what communities are, if they don't know how to limit propagation, the extreme case is you just say, I'm sorry, your clue factor is too low, I'm going to have to de-peer you. Go take some classes from awesome people like Andy and learn about BGP and learn about communities and limiting route propagation. And then, hey, come back and tell us you've gotten clue level up, and then we can talk again. Thanks.
Okay, thanks for the questions. That was a lot of fun after to have a discussion as well. I think that wraps it up then. Thank you ever so much for coming along, and I'll be here during the break if you want to chat. Thanks.